Okay, so find the limit. Now, we can try direct substitution again. If we do, definitely the denominator is 0. Right? In the numerator, you get the square root of 0 plus 1, which is the square root of 1, which is 1. 1 minus 1 is 0. It's indeterminate form, right? However, that's not factorable. And these aren't polynomials, so I can't just factor out a common factor here. We have another technique for that, right? And that's called rationalizing technique. And rationalizing technique, you know, there's two different ways that we've rationalized things in the past, right? If you had something like 1 over the square root of 2, you would multiply by the square root of 2 over the square root of 2, so you get rid of the radical in the denominator. Also, if you had like 1 over the square root of x plus 3, you would multiply by the square root of x minus 3 over the square root of x minus 3. Right? That was the technique when you had like 2 terms in the denominator. Do you remember what we called this factor here? When you just switch the sign? Starts with a C. Conjugate. That's it. You multiply by the conjugate. And when you do that, you get rid of what it is basically, this is the factoring of the difference of squares. The middle terms will cancel when you FOIL it. It's essentially just the square root of x times the square root of x plus 3 times negative 3. That's it. There's no more radicals. Well, in this kind of problem here, we're going to do the same thing. Now, we're not doing it for the same reason because we don't have a radical in the denominator. So we wouldn't say, I got to do this because I got a radical in the denominator. We're doing this because we need to do something to evaluate the limit. And so I'm going to take this outside of the limit just so we can do the math on it down here. The square root of x plus 1 minus 1 divided by the square root of x. Okay, the technique is, this technique, rationalizing technique says, multiply by the conjugate of that term that has a radical in it. So what will be the conjugate of that term? The square root of x plus 1 plus 1. Just change the sign. But if you do that in the numerator, you got to do that in the denominator. Okay. Now, in the numerator, that's a FOIL. Right? That's a FOIL. I'm going to show part of it anyway. I mean, what do you get when you multiply the first terms? The square root of x plus 1 times the square root of x plus 1. It's x plus 1, right? It's like the square root of x plus 1 squared cancels the square root. So that's just x plus 1. Now, the middle 2 terms, which I'm not going to write down, right? The next one would have been the square root of x plus 1 times 1. And the next term would have been the square root of x plus 1 times negative 1. They're opposites. They cancel. That's why we're doing this, so that the middle terms cancel. And then we still have to do the negative 1 times 1, which is minus 1. Okay. Now, in the denominator, we still have all of this to deal with here. But here's the thing. Don't simplify. Just leave it like it is. Don't try to distribute the x or do anything crazy with it, because always there will be some simplification later that if you leave it in this form, it's easier. Right? So I've still got x times the square root of x plus 1 plus 1. Now, in the numerator, I can simplify, right? X plus 1 minus 1, cancel. And now what's left in the numerator? Just x. But now I have a factor of x in the denominator too. They cancel, right? That always happens. That's why you don't confuse things by having distributed that term, right? It's just going to make it harder later on. So at this point, I've got x over this x times the square root of x plus 1 plus 1. And then these cancel. And now I can take the limit of what's left. Limit as x approaches 0 of 1 over square root of x plus 1 plus 1. You see where that is? Make sure that when you cancel these x's there, you still have a 1 in the numerator. Okay? Can you do direct substitution? Yeah, I mean, now if I put in a 0 here, I get the square root of 1, which is 1 plus 1, right? And that's okay, right? It was a problem when it was a 1 minus 1. It's not a problem when it's a 1 plus 1, right? So this is 1 divided by the square root of 0 plus 1 plus 1, which is 1 half. So that's the rationalizing technique. Multiply by the conjugate that's going to get rid of that radical wherever it is.